Welcome to this NPTEL course on robotics, basics and advanced concepts. My name is Ashitava Ghotal and I am a professor in the Department of Mechanical Engineering and Center for Product Design and Manufacturing at the Indian Institute of Science, Bangalore. In the next few slides, I will give you an overview of this course. I will tell you who the course is for, who it is not for, and then what are some of the prerequisites that are required, and details about the course content and the lectures. Okay. So a word about the course. The course is not for high school students and hobbyists interested in robotics. Okay. There is a huge interest in robotics among high school students. They will use kits to show some robots which are doing some task. This is not a course for them. It is also not an introductory or a first course in robotics. Okay, it is not for students who want to learn software tools for robotics, such as robot operating system. It is also not for students who want to find out about AI, ML, and computer vision aspects of robotics. Okay, there are other courses which cover these aspects. This course is for masters and senior undergraduate students in engineering and computer science. It is meant to be an intermediate or an advanced level course in robotics. It is more mathematical in nature. This course is focused towards kinematics, dynamics, control, sensing, and application of serial and parallel robots. Okay, we will have many instances where we model and analyze parallel robots. This course contains recent research done by students at ISC and gives the flavor of some of the newer areas in robotics. Okay, so this course is conducted over 12 weeks, and this slide shows what are the contents in each of the week. There will be assignments in this course. Offline means you will have to do the assignments and submit the solutions. Online means while doing the course, maybe some problems or something needs to be solved. Okay. So in week 1, we will have introduction to robotics, the science and technology which goes behind making a robot. In week 2, we'll look at mathematical preliminaries, how to represent links and joints and other elements in a robot. We will also look at this very important Tennewitt-Hartenberg convention and parameters and some examples. In week 3 and 4, we will look at kinematics of serial and parallel robots. In week 5, we will look at applications of parallel robots. This will show you some 3 applications or 3 ways which parallel robots can be used. Okay, and this is part of the research which was done by students at ISC. In week 6, we will look at velocity and static analysis of manipulators. In week 7, we'll look at redundancy and its resolution. There are many robots which are redundant, meaning that there are many more degrees of freedom than what is required. So how do we model and analyze such hyper-redundant and redundant robots? In week 8, we look at the dynamics of serial and parallel robots. In week 9 and 10, we look at motion planning, linear control, and nonlinear control of robots. In week 11, we will look at wheeled mobile robots. Here again, the focus will be on the mechanics of wheeled mobile robots. We are not going to look at obstacle avoidance or simultaneous localization and mapping and so on, which are also important areas in wheeled mobile robots. In week 12, again, we will look at over-constrained mechanisms and deployable structures. Okay, so the prerequisites for this course are basic high school trigonometry and algebra. There is also a requirement of undergraduate level mathematics. You should be comfortable with linear algebra and ordinary differential equations, and undergraduate mechanics. Some knowledge of programming is required. MATLAB or its equivalent are preferred. Okay, this course will be supported by teaching assistants who will answer your questions. Okay, There are two teaching assistants right now which are assigned. One is Soumya Kanti Mahapatra and one is Pramod Pal. These are both PhD students in the Department of Mechanical Engineering at IISc Bangalore. Okay, so their email ID and mobile numbers are shown here. Let's quickly go through some of the lectures and its contents. The right hand side here shows the rough duration of all the lectures in that week. So each week will roughly have about between 2 and 3 hours. Okay, so in week 1 there are 3 lectures dealing with introduction, a little bit of history of robots and things like that, and then we look at the main elements of a robot and the main techniques for modeling and analysis of robots. In week 2, mathematical preliminaries will be presented, how to represent links and joints and other elements of a robot, and we'll look at examples of DH parameters of some robots. In week 3, there will be 4 lectures. These deal with direct and inverse kinematics of serial robots, and there's very useful notion of theory of elimination, which is used to obtain the inverse kinematics of serial robots and direct kinematics of parallel robots. Okay. In week 4, there are 5 lectures. These deals with basically parallel robots, namely the loop closure constraints in parallel robots, direct and inverse kinematics of parallel robots, a concept of mobility, which is very useful in parallel robots, and then the direct kinematics of Stewart-Gao platform. In week 5, there are 3 lectures. These are applications of parallel robots for sun tracking, force torque sensor, and vibration isolation. Again, these 3 are the work of research students in our department. In week 6, there will be 5 lectures. These deal with linear and angular velocity of links, Jacobian matrix for serial and parallel robots, singularities in serial and parallel robots, and statics of serial and parallel robots. In week 7, we study hyper-redundant robots, redundancy in human arm, and flexible robots. In week 8, there are 4 lectures dealing with Lagrangian formulation, equations of motion of serial and parallel robots, forward and inverse dynamics of robots, and recursive formulation of the equations of motion of a robot. In week 9 and 10, we look at motion planning, control of a single link and multi-link robots. We look at nonlinear control of multi-link robots, force and hybrid position control, and advanced topics in control. These are like 7 lectures in these 2 weeks, 3 in 9 and 4 in 10. In week 11, we will look at kinematics and dynamics of wheel mobile robots and on flat and uneven terrain. And this will be covered in 3 lectures. In week 12, there are 2 lectures, and these are lectures on over-constrained mechanisms and deployable structures. Okay, this is one of the shortest week with 1 hour and 22 minutes. Most lectures are prepared using LaTeX and Beamer. Okay, a few lectures were also prepared in PPT. The lectures may contain errors in text and narration. So for example, in this slide on kinematics of parallel robot, you can see that there is a typing mistake. Okay, instead of serial manipulator, it is written some whatever. Okay, and the students, Soumya Kanti Mahapatra and Pramod Pal, have gone through each of these slides and these lectures, and they have annotated, they have said what is the error here. Okay, so annotations are also there. So I request all the students of this course to let me know what are the errors. Okay, I am waiting to hear from the students. They will find more errors. They will all be collated and then corrected. Okay, the finder will be acknowledged in the course update. Acknowledgements. These lectures were previewed by Soumya Kanti Mahapatra, Pramod Pal, and Yogesh Pratap Singh. These are the PhD students working with me. Okay, as I said, many of these errors which were found, okay, both in audio and lectures, are annotated by Soumya Kanti Mahapatra. I showed you an example in the previous slide. A large amount of the material of this course is from the research work of masters and PhD students, both past and present, and I am very grateful and their work is acknowledged. The help of the NPTEL office and staff is also gratefully acknowledged. Okay, so thank you, and I hope you like this course.